Okay, let's go ahead and get started. Let me close my door. Okay. Okay, so I want to go over what I just posted on Canvas about an hour ago. Um, it's called Hypothesis Test and Review. I want to make sure that we have time to go over this. I feel that it's more important that this be a priority to go over than part 2 review at this point. Um, I want to make sure that we have time for both of them. But if I have to cut something out, then it's going to have to be the later portion of the part 2 review, because most of that you should be able to do on the calculator anyway. And I just want to make sure that we have the calculator stuff down uh, in in um, in preparation for the exam. Okay, so this is just going to be hopefully a short 12 questions that we can go through. That basically is just calculator. It's all calculator focused. Okay. Okay, so let's go through number 1 here. It says to help consumers assess the risk they are taking, the Food and Drug Administration publishes the amount of nicotine found in all commercial brands of cigarettes. A new cigarette has recently been marketed. The FDA tests the cigarette gave the mean nicotine content of 26.4 milligrams with a standard deviation of 2.0 milligrams for a sample of 90 cigarettes. Construct a 95% confidence interval to estimate the true mean of the content. So 95%, and we want this to be a confidence interval. Okay, so this is strictly a calculator problem. And so we're going to go to do a mean interval. Well, what's a mean interval? Well, that's a t interval. So we're going to go to tests, and we're going to go down to where it says t interval. I believe that's 8. Okay, and we're going to use the stats that they give us. They tell us that the mean was 26.4. The standard deviation was 2.0. And the sample size was 90. The confidence level is 0.95. And I want to hit calculate. And it gives me an interval of 25.981 and 26.819. Okay. That means that I am 95% confident that the true mean is somewhere between these two numbers. Okay, the true mean. Okay, that's what we're estimating. We're estimating the true mean for the nicotine content. Okay. Okay, so get rid of this. So here's kind of what I should have gotten. Okay, erase this. Okay, when I do the problem. So T interval is what we're looking for. X bar is 26.4, S is 2.0, N is 90, and the confidence level is 0.95 for a total of 25.981. Okay. Okay, let's try the next one here. Company is interested in estimating mu, the mean number of sick days taken by all of its employees. The firm statistician selects a random 65 personnel files and notes the number of sick days taken by each. The sample has mean of 12.2 and a standard deviation of 10 days. Estimate mu with a 90% confidence interval. So it's basically the same thing that we did before. Another confidence interval, another t interval. So let's go and do a t interval on means. Okay, for number 8 here, t interval. Okay, and it says that the mean was 12.2 days. The standard deviation is huge, it's 10 days. Okay, some people took a few days and some people took a lot of days. Okay, the number of people in the sample was 65, and this time we want a 90% confidence interval. And I'm going to calculate that, and it's between 10.13 and 14.27. 10.13 and 14.27. Yep, that's correct. Okay. Okay, find the z-score. Okay, find the z-score for the 75th percentile. Okay, so the 75th percentile z-score, oops, not into shape. Let's get off of that. Just want to draw. Erase that. Okay, 70. Whoa, you're making me mad. You don't want to make me angry. You're not going to like me angry. Get off into shape. Get off into shape. Go away. There you go. Okay, finally. Okay, we want the 75th percentile. That means that everything here is 0.75. So how am I going to find the z-score for the 75th percentile? Well, I'm going to use inverse norm. Okay, so second vars, inverse norm. The area is 0.75. Mu is 0, and sigma is 1 because we want a z-score. And it's 0.674, I believe. Yeah, 0.674. Okay. What's the z-score to be used for a 96% confidence interval? 96% confidence interval. Well, confidence interval says that this is 96%. I want the z-score, which is going to be the positive critical value here. Okay, so that means that I've got 2% over here, and I've got 2% over here, making this a total of 98% below that line. So I'm going to use inverse norm for 98%, this time 0.98. And it tells me that it is 2.05. Okay, let's see what we got here. And that is correct, 2.054. Okay, inverse norm. Okay. Number 4, a survey of 80 fatal accidents showed that 46 were alcohol related. Okay, construct a 94% confidence interval for the proportion. Now we've got a proportion of all fatal accidents that are alcohol related, round to 3 decimal places. So we want a proportion. Okay, so this is going to be a prop z. Okay, one prop z interval. One prop z interval. So let's go to stats, tests. Let's go to one prop z interval. Okay, which is A here. A is one prop z interval. Okay, it says that a survey of 80, well, that's going to be n is equal to 80, showed that 46, that's going to be x, that's the number, okay, of, well, we would call it successes. This isn't really successes, this is more failures, okay, but we're testing the failures here. Okay, that were alcohol related. Okay, I guess any fatal accident is not a success. Okay, but the desired results that we're looking at are the ones that are alcohol related. So X is 46. Construct a 94% confidence interval. Okay, so what's X? X is the 46. Okay, N is the 80. Okay, and the confidence level is 94%. Let's calculate that. That's going to go from 0.471 to 0.679. Okay, 0.471 to 0.679. Okay, and that's correct. Okay, state the null and alternative hypotheses indicating which is the claim being tested. Okay, the lifespan of a television is at least 7 years. So what's being tested here, mean or proportion? Okay, the lifespan of a television is at least 7 years. That's going to be the mean. Okay, so HO is that the mean, mu, is equal to 7. Okay, the alternative is that's going to be less than 7. Okay, so let's see what we got. Or sorry, it's the greater than 7. It's more than 7, yeah. So alternative is mu equals 7 and, or sorry, the null is mu equals 7 and the alternative is greater than 7. Okay, because it's at least 7 years, which means 7 or more. Okay, that's the claim. Okay, the time spent on homework for A students is significantly different from 30 minutes. Okay, it's significantly different. So significantly different, that's going to be a not equal to symbol. Okay, so that's going to be mu again. Okay, so mu equal to 30 is going to be my null. Not equal to 30 is going to be my, not equal to 30 is going to be my alternative. Okay, the majority of Americans cannot name the capital of Burma. Well, what's majority mean? Majority is greater than, okay, majority is greater than 50%. Okay, or 0.50. That's what a majority means. It's greater than 50%. So that's the claim. Well, the claim, because it's on an equal sign, that's going to be my alternative. So what is my null? My null is that the proportion, okay, here is going to be equal to 50%. My alternative is going to be that the proportion is greater than 50%, which is a majority. Okay, simple majority. If I can find the, oh, there it is. It's up here. Go away. I covered it with my majority. Go away. Go away. There we go. Boom. Okay. And there. Okay. Okay, suppose in 5B, okay, 5B here. Okay, suppose in 5B you reject the null. State a conclusion in a sentence about the claim. So if I reject the null, then the conclusion is that homework for A students is significantly different, that there is a significant, okay, that there is sufficient evidence to support, okay, that the amount of time spent on homework for A students is different than 30 minutes. Okay, so let's see how that's stated. Okay. Okay, suppose you reject the null hypothesis, state the conclusion. Okay. We cannot conclude, this might be wrong. We cannot conclude that the time spent on homework for A students is significantly different from 30 minutes. Suppose in 5B you reject the null. Okay, I reject the null. State the conclusion in a sentence about the claim. The time spent on homework for A students is significantly different. That's the claim. Okay. So, no, that should not be cannot. That should be can. We can conclude that time spent on homework for A students is I'll have to go back and change that. Okay, is significantly different from 30 minutes. Okay, so we can conclude that time spent, okay, is different if we reject the null. If we reject the null and we go with the alternative. Okay, number 7, calculate the p-value for each of the following statistic. Okay, for mu, that's a t value. Okay, and so what's the p-value? This is going to be a t-score. Okay, so the t-score is equal to negative 2.73. Okay, and the same with B is we're going to be doing the same thing. In order to find out where that is on the t distribution, negative 2.73, we're going to look for the probability that we go up to that value. Well, this is a t-CDF, okay? Instead of a normal CDF, it's a t-CDF, because normal is for z's, this is for t's. Okay, so this is a t-CDF, so we're going to go second vars, okay, t-CDF. Okay, the lower is negative infinity, the upper is negative 2.73. They want the degrees of freedom. So if the number in the sample is 20, then the degrees of freedom is equal to 19. It's 1 minus the sample. So we're going to go 19 here. Okay, and hit paste, and we get 0.006. 0066, does that correspond to what we have? Okay, yeah, 0.007. Okay, they're rounding to the nearest thousandth there. Okay. Okay, for the next one, same thing. It's a t-score that we're looking at. So this is negative 1.18. Okay, I can just go and do the exact same thing we did before. Oops, go to second vars. Okay, a t-CDF. Okay, negative infinity to negative 1.18. 1.18. And I want to go, and the degrees of freedom this time is 74. And I'm going to hit paste, and we get 0.121. Okay, 0.121. Hopefully that works out as well. Okay. Okay, oh, they're looking for the p-value. Okay, so the p-value, in this case, because it's not equal to, we have to actually double it. Okay, so let me show you why we have to double it. Why it's times 2. Because it's not one-sided, it's double-sided. Okay, so if we have our t-score, right, and we have not equal to, then that means that it's two tails. It has two tails. And the lower one is negative 1.18. The upper one is 1.18. But we need two tails here. So if I just do the t-CDF up to the negative 1.18, that gives me 0.121. But over here, I would have 0.121 as well, and so I would double it to get the 2.242. Okay. Okay, number 8. The Servwell Bank recently surveyed its customers and found that 250 checking account customers selected found that of the 250 checking account customers selected, 110 of them had savings accounts. Tesla claimed that less than 50% had savings accounts. Okay, use the significance level of 0.05. Okay, so we want to test this claim. Okay, so HO is going to be, okay, that the probability is equal to 50%. HA is that the probability is less than 50%, because that's what they're saying. They're claiming that they have less than 50%. Okay, so Number two is, the test. What's the test that we're going to use? Okay, we're going to use a one prop Z test. A one prop Z test. Number three, are all the conditions met? Is it independent, random, and is n times p and n times q greater than or equal to 10? Okay, so we have 250 as n, so I'm going to say yes on that one, especially if I take 250 times 0.5, that's going to be 125. So 125 in each of these, that's going to work. Okay, 4 is to calculate the p-value. Okay, so what's going to be our p-value here? Well, we just have to use the calculator to help us do that. So we're going to go stat tests. Come on, go over tests, and we want to test the claim that less than 50%. So we want a one prop Z test. Okay, so that's number 5 here. Okay, what's the null probability? It's 0.5. How many had savings accounts? 110. How many total customers? 250. We want to test the claim that 50% of the accounts, or sorry, that less than 50%, so less than. Okay, and then we calculate and we find our p-value to be 0.02. P equals 0.02 or 0.03, we'll put 0.029, which is less than 0.05. So what's our conclusion here? Well, our conclusion, okay, I'll just write it over here. Our conclusion is that we would reject the null and we would accept the alternative. Okay, our conclusion is that there is sufficient evidence to support the claim that less than 50% of the customers had savings accounts. Okay, so that's our conclusion. Okay, number 5. Conclusion. Okay, number 9. Test the claim that the mean number of sneezes per day is 3 by using a sample of 25 with a mean of 4.5 and a standard deviation of 2.6. Okay, so what's the null? The null is that mu, okay, would be equal to, what's the claim? The claim is that that the number of sneezes per day is 3, right? Okay, so mu is equal to 3 sneezes per day. Okay, HA is that mu is what? What do we want to test here? Not equal to, maybe? Let's see, the mean claim with a mean of, it doesn't tell us, so we're just going to go with the not equals since we don't know if they're looking for bigger or smaller than 3. I'm going to go with not equals to be on the safe side. Since I don't know, I'm going to default to not equals. Okay, 2, what type of test is this? This is going to be a t-test. T-test, because it's mean. Okay, number 3, is it independent, random, and is n greater than or equal to 30? Okay, we're going to say that 25 is close enough. Okay, and so we're okay there. Okay, 4, we're going to find the p-value. Okay, so we're going to go to the calculator on that one. Okay, so stat test, and this is going to be a t-test. Okay, so what is mu sub 0? That's 3 sneezes. What is x bar? Okay, so what's X bar in this case? The average that we got was 4.5. What's the standard deviation? 2.6. And how many people in the survey? There was 25. And we're going to go with not equals. Okay, not equals. So let me just make sure I plug that in correctly. 3, 4.5, 2.6, 25, and not equals. Yes, let's calculate that. P-value is 0.008, very small, which is less than 0.05. So what does that mean that we're going to do? It means, once again, we reject the null and we accept the alternative. Okay, what is the alternative? The alternative is that there is evidence to support the mean number of sneezes is not 3 per day. Okay, not 3 per day. Okay. Wait, give the conclusion in a sentence addressing the claim that the time of day spent on transportation is at least 5%. Okay, so here they say that the proportion of the day is 5%. We're saying the alternative is less than 5%. They give a p-value of 0.03, a significance level of 0.05. So again, what are we going to do? We're going to reject. Okay, since 0.03 is less than 0.05, we're going to reject the null and accept the alternative. It says write this in a sentence. Okay, once again, there is evidence to suggest that the proportion of time spent on one's commute is less than 5% of their day. Okay.
Professor, I thought that when the p-value is less than the significance level, we fail to reject the null.
No, it's when it's bigger.
When it's bigger, we fail to reject. Oh, so when it's smaller, then we do reject the null?
Yes.
Okay, thank you.
Okay. Okay, let's head into these last three here. Okay. Survey was done for the weights of 12-ounce potato chip bags. Sample of 60 bags. There was a mean of 11.97 ounces with standard deviation of 0.05 ounces. Test the claim that the mean was less than 12 ounces. Use a significance level of 0.05. Okay. So number one, what are we testing? We're testing that the mean should be 12 ounces. If it's not 12 ounces, they're ripping us off. Okay, what is our alternative? Alternative is that they are ripping us off. Okay, the alternative is that it's less than 12 ounces. Okay, number two, because this is mu and it's a hypothesis test, it's a t-test. Okay, number three, is it independent? Sure. Is it random? Sure. Is the sample size n greater than or equal to 30? Well, yeah, 60 is greater than or equal to 30, so check. Okay, number four, let's calculate the t-test. Okay, what is, well, let's say that, what is x bar? X bar is equal to 11.97. What is s? S is equal to 0.05. What's n? N is equal to 60. Okay, and so what's the p-value? Well, let's go to the calculator for that. Stat t-test. Okay, so stats, this is 12. Okay, x bar, okay, is 11.97. Okay, standard deviation is 0.05. That was out of 60 bags of chips. and we want less than 12 to be what we're comparing against, and we're going to calculate. When we calculate this out, we get an extremely small p-value. The p-value becomes 0.0000966. Okay, so extremely small p-value. Okay, this 10 to the negative 6, this e to the negative 6 here, that means 10 to the negative 6th power. So it's extremely small. Okay. It's because we had such a small standard deviation and we had such a large sample size. Okay, that does tell me that they're ripping us off. Okay, so evidence suggests I am ripped off. Okay, I'm not getting as much chips as they're claiming. Okay, because I would reject the null and I would accept the alternative. Okay. Okay, number 12, the sample proportion from group A consisting of 100 items is 0.39. So this is sample proportion. So that should key me off to say, hey, I'm probably going to use a prop test on this one. But it also tells me that I have groups A and I have group B, right? Group A and group B. So, oops, let's undo that. Can I undo that? Undo, undo. There we go. Okay. Okay, so there we go. So we have a group A and we have a group B. So there's going to be two props involved here, two proportions. Okay, the sample from group B consists of 100 items and is 0.29. Test hypothesis, there is no difference between group A and group B. Okay, no difference between group A and group B. Okay, so what's the null hypothesis? The null hypothesis is that PA is equal to PB, but there's no difference. What's the alternative? Well, the alternative is that there is a difference. Okay, no difference, or there is a difference. PA is not equal to PB. Okay, number 2. Okay, this is going to be a 2 sample prop. Okay, test. Okay, 2 sample proportion test. Okay, z-test, I think. Okay, number 3, independent, sure, random. Sure is n times p greater than or equal to 10 for the first group. Yeah, 100 times 0.39 is 39. So this is 100 times 0.39, which is 39, which is greater than or equal to 10. Okay, what about n times q for the first group? Is that bigger than 10? Yes, 100 times 0.61 is 61, which is greater than or equal to 10. What about for the second group? That's for group A. What about for group B? Oops, other way around. Okay, what about for group B? N times P, is that greater than or equal to 10? Well, that's 0.29 times 100. 100 times 0.29, which is equal to 29. So that checks. These all check. Okay, and n times q is greater than or equal to 10. This is 100 times 0.71, which is 71, which is greater than or equal to 10, so they all check. Okay, 4 is to actually find the p-value. Okay, so let's find the p-value. This is going to be stat test, and this is a 2 prop. This is a 2 prop z-test. 2 prop z-test. So this is number 6. Okay, 2 prop z-test. I guess I should put this. Oops. Let's get rid of that again. There we go. Okay. 2 prop z-test. There we go. Okay, that's what it says in the calculator. Okay, so what's x1? X1 is going to be the 39 Okay, x1 is the number of successes. Okay, the number of successes is that 39. So that's 39 out of 100. Okay, in the first group, 29 out of 100 in the second group, 29 out of 100 in the second group. Okay, and this is going to be a not equals. And so I'm just going to hit calculate. Oops, what did I do wrong there? Stat tests. Okay, one prop z test or two prop z tests. Okay, so 30. Oh, this should be 100. I don't know why. 100. Enter. That should be 100 too. 100. Enter. Boom. Calculate. Okay, perfect. Okay, so this gives me a p-value of 0.135, which is greater than 0.05. So when it's greater than, what do? We fail to reject the null. Okay, we fail to reject the null. Therefore, there is evidence that the groups are the same. Evidence to support groups are similar. Okay. Okay, number 13. The sample mean from group A, okay, consisting of 100 items, is 25 with a sample standard deviation of 5. Okay, so this is now sample mean of group A and group B. Okay, so sample mean from group B consisting of 100 items is 27 with a standard deviation. Test hypothesis, there is no difference between the two groups. So now we're going to do the exact same thing, but we're doing it with means now. Okay, so two samples with means. Okay, so this is going to be HO is mu A is equal to mu B. That's my null. My alternative is that mu A is not equal to mu B. Okay, number 2. So what is this one going to be called? Let me make sure I get the correct calling. This is a 2-sample t-test. Okay, 2-sample t-test. So 2-sample t-test. Okay, 2-sample t-test. Okay, and so number 3, is it independent? Sure. Is it random? Random. Sure. Is it 25 or above? Sure. N is greater than or equal to, okay, 30. Sure. We'll go with it's okay for both of them because it's a t-test. We're not as stringent about that 30 there. Okay, is n greater than or equal to 30? Sure. Okay, for both of them. Okay, number 4, let's calculate our values here. Okay, so x1 is going to be, oh no, it's 100 items. I'm sorry. They're both 100 items. Get back there. Okay, so don't want to do that either. Okay, so n is greater than or equal to 30. Yes, because n equals 100 in group A and n equals 100 in group B. So greater than 30. Check. Okay, so what's x? X is going to be 25 in the first group. What's the standard deviation? 5. What's the number of items? 100. Okay, what's x2? X2 is 27. What's the standard deviation? It's 4. Okay, and we want not equals 2. That's correct. Okay, pooled. No, we don't want pooled. And then we want to hit calculate. Okay, so what's the p-value? The p-value is equal to 0.002, okay, which is less than 0.05. So if it's less than, then what do we say? Do we accept the null or do we reject the null? We reject the null. and we accept the alternative. The alternative is that they're not equal to. So number 5 is that there is sufficient evidence to suggest that there's sufficient evidence to suggest that that there is a difference between group A and group B. Okay. Okay, so again, I wanted to make sure that we had time to go over the calculator stuff, because this is going to be 5 of the problems. 5 of the problems at the very end, you're going to do 1 through 5, just like this at the very end. I want to make sure we had time to go over this. Okay, I also gave you the key to this thing as well. Okay, let's go on to part 2 of the review. At this point, we may get through all of this, we may not get through all of it. The first half is really just theoretical. The second half is computing stuff, but I may skip over some of it, since on the exam, you're not going to be computing stuff by hand. You're going to be computing stuff on the calculator. Okay. Okay, so this is a Unit 3 review. Leave this out. Or sorry, this is exam 3 review part 2. Okay, exam 3 review part 2. Okay, write the symbols. Okay, write the symbols for each term. Okay, the mean of the population mean. Well, what's population mean? That's mu. Okay, the mean of a sample. What's the mean of a sample? That's x bar. What's the population proportion? That's p, not to be confused with the p value. What's the sample proportion? That's p hat. P hat. What's the standard deviation of a population? Standard deviation of population, that's sigma. Sigma. What's the standard deviation of the sample? That's S. Okay, or sometimes referred to as S of X. Okay, what is the mean for the sampling distribution of sample means? The mean for the sampling distribution of sample means. Okay, that's mu of X bar. Okay, that's the mean for the sampling distribution of sample means. So if you see mu of X bar, that just means that it's mu of the sampling distribution of sample means, and this is where we get our t distribution from. Distribution. Okay, the mean for the sampling distribution of sample proportions. Okay, that's mu of p hat, sample proportions, and this is our z distribution, or our normal distribution also. Normal distribution. Let me mute everybody here. Mute all. There we go. Okay, I, standard deviation or the standard error for the means. What's the standard error for the means? Okay, standard error for the means is sigma of X bar. Okay, that's the symbol, sigma X bar. Okay, that's the standard deviation for the sample means. What's the standard deviation for the sample proportions? That's sigma of p hat. What's the sample size? That's easy, that's n. And what's the number of successes when calculating the sample proportion? That's x. Number of successes is x. Okay, number 2, what's the difference between a parameter and a statistic? Well, parameter is for a population, and a statistic is for a sample. Okay, of the two, which one can vary and which one is fixed? Well, the sample can vary, and the population, or the parameter can vary, or the statistic can vary. Which one are they looking for? The statistic can vary. Statistic can vary, and the parameter cannot vary. That's fixed. Okay, of the two, which one is usually known? Or sorry, of the two, which one is usually unknown? Well, it's the parameter. The parameter is usually unknown. Okay. What are the two parameters we often used in testing or estimating in Unit 3? Okay, well, it's mu, okay, or p. Okay, those are the parameters that we're often interested in testing, okay, or estimating in Unit 3 here. What is the purpose of a confidence interval? To estimate the true value of a parameter. Estimate the true value of a parameter. Okay, estimate the true value of a parameter. What is the purpose of a hypothesis test? Okay, to test a claim about a parameter. Test a claim about a parameter. What is the definition of p-value? It's the probability that the null is true. Okay, it's the probability that the null is true. Okay, I might go with a picture on this one, right? Because the null is in the middle here. This is the null. Okay, that's the null. And what's the p-value? The p-value is the probability, okay, that how far you are from the null. Okay, it's a probability that the null is true. Well, if you're right on the, if you're right next to it, then you don't, then you're boom right there. Okay, but it's a probability that the null is true. Okay, how far away from the null you are. What does the standardized test statistic of hypothesis test tell us? What does the standardized test statistic, okay, so we're standardizing this, right? Standardizing it. Well, anything that's standardized, let me get rid of this guy real quick. Anything that's standardized tells me that it's standard normal, which means that it's probably a z-score, right? Okay, z-score is a standardized score, and that tells me how many standard deviations I am away, okay, from the claimed value. Again, say that this is mu null. Okay, how far away am I with my x bar? Okay, right? How far away? How many standard deviations am I from the mean? From the, this is the claim, and this is the observed, right? So it's the number of standard deviations away the observed is from the claim. Oops. Go away. Claimed parameter. Okay. What does it mean to be 90% confident? Okay, that means 90%. Okay, it means 90%, okay, of all samples contain the true parameter. Okay, 90% of all the samples contain the true parameter. what is the level of significance? What is the most common level of significance that we use? Okay, what is a level of significance and what is the most common one that we use? Okay, level of significance is a threshold for rejecting the null. Okay, alpha equaling 0.05 is most common, or our default. Okay, it's our default. What's a primary way of determining if we are estimating a proportion or a mean? Okay, proportion or a mean. Okay. Okay, proportions generally are categorical. Okay, it's like, 5 out of 10 dentists prefer Crest. Well, Crest is not a numerical or quantitative value. Crest is a type of toothpaste, and so proportions are categories. Okay, that 5 out of 10 is like, 5 out of 10 people think blah blah blah, whatever. Okay, that's a category. Okay, it's not numerical. Okay, means are generally numerical. Okay, boys tend to be 3 inches greater than girls on average. Okay, it's probably not true in middle school. Okay, whatever. It's usually numerical. Okay, or quantitative. Okay, as opposed to qualitative. That's numerical, by the way. Okay, what are the 5 steps to follow whenever performing a hypothesis test or building a confidence interval? Okay, we just went through a lot of that. Okay, define the hypotheses. Okay, number 2. Okay, state the test. Number 3, check the requirements. Okay, number 4 is do the calculations. And number 5 is state your conclusion. Okay, as a sentence. Okay, as a sentence. Okay, how do we check large enough requirements for proportions? Okay, well, n times p is greater than or equal to 10, and n times q, which is 1 minus p, okay, is greater than or equal to 10. Okay, put that underneath. Okay, how do we check large enough requirements for means? Okay, usually n is greater than or equal to 30. Okay, I might lower that to 25. That would be fine. Okay, say that it's less than 25. It's fine. Okay, how do we know when to use the Z method versus T method? Okay, so Z is for proportions, or when sigma is known. Okay, T is otherwise, is for means, and sigma is unknown. Okay, so T is means and sigma is unknown. Okay, how do we know when to build an interval versus performing a hypothesis test? Okay, so an interval asks us how many Okay, we're looking for a value, an interval. We're looking for a value, okay, how many or how much. Okay, a test, a hypothesis test, we're comparing a claim. We're comparing to a claimed value. Okay, the interval, we don't have a claimed value. We're looking for the value. Okay, we just have statistics. Okay, what does the critical value of a confidence interval represent, and how do you find it? Okay, critical value of a confidence interval. Okay, so critical value of a confidence interval. Okay, the critical value, okay, which is our Z star or our T star. It's either Z star or T star. Okay, that critical value is found by the number of standard deviations away from the parameter that we're looking for. Okay, the parameter. Okay, number 14. How do you build a confidence interval when you have the point estimate and margin of error? Okay, so point estimate is just going to be our mu or our p. So it's the point estimate. Let me do it like this. The point estimate plus or minus the margin of error. Okay, and what does that look like? Okay, what is the point estimate used for estimating the population proportion P? Well, for proportion, okay, it's P hat plus or minus Z star times the square root of PQ over N. That's for proportions. The P hat is our point estimate, and our Z star, okay, our Z star times the square root of P over Q, PQ over N, that's our margin of error. Our standard error is the PQ over N square root. For means, okay, this is going to be X bar plus or minus T star for means, and then it's S over the square root of N. So our point estimate is X bar, T star, S over square root of N. Okay, fill in the blank correctly, appropriately. Since the p-value is less than 0.05, so if p-value is less than 0.05, so p-value is less than 0.05, what are we going to do? If it's less, what do we do with the null hypothesis? We reject the null hypothesis. We reject the null hypothesis. We have sufficient evidence to support the alternative. Okay, the alternative. Okay. If the p-value is large, if the p-value is greater than 0.05, okay, we fail to reject. We fail to reject the null hypothesis. We have insufficient evidence to support, that should be two P's there, support the alternative. Okay, name what each formula below calculates. Note, you don't have to memorize these, but you should be able to recognize them on a formula sheet. Okay, and I did provide these on a formula sheet for you. Okay. Okay, S over the square root of N or sigma over the square root of N. Well, that's standard error, okay, for means. Standard error for means. Okay, depending upon if sigma is known or if sigma is not known. Okay, what's T star times S over N? Well, we just talked about that. That's the margin of error for means. Margin of error for means. What about C here? The square root of P naught 1 minus P over the square root of N. What is that going to be? That's the standard, or sorry, that's the, standard error. Standard error for for proportions. This is for a hypothesis test. Okay. Which is different than the standard error for proportions for D. Okay, this is the standard error. Notice that we use P hat in D and we use the null hypothesis in C. Why can't we use the null hypothesis or the parameter, okay, for D when we have a confidence interval? Because we're not given that information. We're only given P hat for a confidence interval. So this is for proportions, but this is a confidence interval, okay, instead of a hypothesis test. Okay, E, what's E going to be? Well, this is the margin of error. Okay, margin of error. And once again, only the confidence interval have margins of error. So this is margin of error for proportions. Okay, what about this one, F? F is Z star E, that's the error, margin of error, times 0.25. Well, this is the minimum number, or sorry, we'll say sample size, minimum sample size for a given error. And this is for proportions, given proportion error. Okay, for a given proportion error. Proportion, we'll say margin, so we know which error we're talking about, margin of error. Okay, what about the next one? That's the minimum. Minimum sample size for a given mean margin of error. Okay, and you always round up for these. Okay, always round up. Okay, always round up. Okay. So some of the stuff they want you to calculate by hand for the next of these, I'm going to just kind of quickly go through some of this stuff. Again, a lot of this you'll be able to do on the calculator and you won't have to do by hand. But I'll just quickly go through these next 8. Okay, a recent study finds that 305 randomly selected students from a large high school, 217 responded that they enjoy reading, write the expression that would build a 99% confidence interval. Okay, so for a confidence interval, okay, we would have P hat plus or minus Z star times the square root, okay, of 0.71, or sorry, times the square root of P times Q over N, okay? Okay, so what's P hat going to be? Well, P hat is going to be X over N. P hat is going to be the 217 over 305, which is about 0.71. Okay, Z star for 99% if you were to get a Z star, I'll do this once on the calculator, but how do we get a Z star of 99%? Okay, well, a Z star for 99% for a confidence interval means that 99% is in the middle, which means that 5% is on the out, or sorry, 0.5% are on the outside. So this is really, I want the critical value for 99.5%. Okay, so I would go to stat, or sorry, not stat, I would go to second vars, I would go to normal CDF, and I'd say, well, what do I want the, is that what I want? No, I want inverse norm, sorry. Okay, I want second vars inverse norm, and I want to know what is this going to be up to 99.5% or 0.995. Okay, that'll give me 2.575 or 2.558. So this is 2.58 times the square root of 0.71 times 0.29 all over the total number, which is 305. And they don't ask us to calculate this out, so we just leave it like so. Okay, you could plug that into the calculator and get your confidence interval, but you really wouldn't even want to do that because you could just use the calculator for this. Okay, they're just asking you to set it up. Okay, number 19. A recent study finds out that 210 randomly selected students from a large high school, 69, responded that they enjoy reading for leisure. Okay, writing the equation that would calculate the test statistic used to test the claim. Okay, P is equal to 0.28. Okay, so first, again, I need to find out, well, what's P hat? Okay, P hat here is 69 out of 210, which is about 0.33. So what's the Z statistic going to be? It's going to be 0.33 minus, okay, it's going to be mu minus mu, I'll write it out. It's, sorry, X bar minus mu. It's P hat minus P naught all over the square root of PQ over N. Okay, and so this is going to be 0.33 minus 0.28 all over the square root of 0.28 times 0.72 all over the total number, which is 210. Okay. So again, we're not calculating it out, we're just setting it up. Okay, a recent study finds out that 30 randomly selected students from a large high school, the mean number of hours, so this is mean now, was 6.2 with a sample standard deviation of 1.8. What is this test statistic used to test the claim? So this is going to be a T statistic. So this is going to be X bar minus mu over S over the square root of N. So X bar was the mean was 6.2. What is the test to test the claim that the true was, yeah, so this is going to be 6.2 minus 5.9 all over 1.18 all over the square root of 30 randomly selected students. Okay. Okay, 21. Nursery owner claims that recent drought stunted the growth of 15% of all of her evergreens. The botanist tests the claim by examining a simple random sample of 2,300 evergreens and finds 25% of the trees. Write a formula that would calculate the value of the test statistic. Okay, so we're running the hypothesis test here. It's on proportions. So we know that for proportions, it's the Z statistic. Once again, this is going to be P hat minus P naught all over the square root of P naught Q naught over N. What's P naught in this case? Okay, P naught is 425 over 2300. So 425 divided by 2300 is about 0.18. So I'm just going to go 0.18. There's going to be a lot of rounding error, but that's okay. I'm not calculating anything out at the end anyway. Okay, I'm just setting it up. Okay, 0.18 minus what's the claim? The claim is 0.15 all over the square root of 0.15 times 0.85 all over the sample size of 2300. Okay. Okay, 22. A recent study finds that out of 30 randomly selected students from a large high school, the mean number of hours studied per week is 6.3 with a standard deviation of 1.5, right? The expression that would build a 90% confidence interval. Okay, so this is going to be T, okay, a T distribution because it's mean. Okay, and so we would need TCDF in this case to get us our T star. I want our T star here, T star. Okay, the T star for a 90% confidence interval. So it's got to be 90% here, which means that I've got 5% here and I've got 5% here. So in order to calculate that T star, okay, T star, I've got to do 95%. Okay, so this is going to be second vars. Let's go to TCDF because it's means. And we're going to go to the upper, which is now 95%. Degrees of freedom, how many in the study? It was 30, so that's going to be 29 degrees of freedom. Paste, and that comes out to 0.825. All right. No. I don't want TCDF. I want inverse T. I did this wrong. My bad. I want inverse T. Inverse T. Sorry. Okay, let's redo this. Inverse T. I don't want TCDF. Okay, inverse T. What's the area that I want? This is what I want. What's the area that I want? I want the area to be 95%, 0.95. What's the degrees of freedom that I want? 29. Paste. Okay, that's more like it. I'm looking at 1.7. T star is 1.7. So what I'm going to do, I'm going to say that this is 6.3 plus or minus. Okay, so it's going to be my X bar plus or minus my T star, which is 1.7, times S, which is 1.45, all over the square root of N, which is 30. Okay, so it says write the expression that would build. Yeah, so we're just writing the expression. Okay, and then you can calculate that out. Again, we could do this all in calculator using a T interval. They're just wanting us to calculate it out. Okay, the 23 and 24 you can't do on the calculator. You have to kind of do this by hand. And I'll show you why. It says an 80% confidence interval is used to estimate the proportion of internet users who use multiple tabs when they surf the web. Find the proportion of the sample, okay, who use multiple tabs. So we want the sample proportion. We want P hat. What was P hat? Well, this was a confidence interval, right? So to find the confidence interval, we had to do P hat plus the margin of error, right? P hat plus or minus the margin of error. Well, P hat's going to be right in the middle of these two values. It's going to be in the middle of 0.411, okay, and 0.509. It's going to be right in the middle. So how can I find something that's right in the middle? Well, I take the average of them. So I average these. So it's 0.0509, okay, plus 0.411 0.411 and then divide by 2. So 0.411 plus 0.509, okay, and then divide by 2, and we get 0.460 is my sample proportion. That's right in the middle. Okay, the next one, how do we find the margin of error? Okay, this is a 90% confidence interval. We want to find the margin of error. Well, that's what we were adding and subtracting in the last, that's the difference, right? That's the differences. So if we look at the steps again, right, this is 6.98, this is 7.62. Well, I'm going to need to add and subtract the same amount, right? So let's say that's mu, right? So wouldn't I have to add and subtract the same amount, right, from mu? So wouldn't I really, to go from 6.98, wouldn't I add the same amount twice? Does that make sense? First, I go from 6.98 up to mu, and then I go from mu to 7.68. That's, or 7.62. That's what's in the middle here, right? So we could find the middle and then subtract that from either side, or we could just say, hey, the difference here between 7.62, right, and 6.98, the difference, if I take half of that, that's going to give me my margin of error. If I take half of the difference between the two, that will give me my margin of error. So 7.62 minus 6.98. Now make sure that you do the subtraction first. Divide that by 2, and I get 0.32. So the margin of error here is 0.32. Okay. Okay, number 25. A study of 200 students at a local college found the sample drank a mean amount of 212 milligrams per day. A study reported a margin of error of 18 milligrams with a 95% confidence when estimating the true mean. Find the upper and lower bounds of the confidence interval. Okay. So find the upper and lower bounds of the confidence interval. They reported a margin of error of 18. Well, they're already giving us the margin of error. We don't have to calculate the margin of error. They're already giving us the margin of error. So this would just be 212 plus the margin of error and 212 minus the margin of error. Okay, so it's just going to be my point estimate plus the margin of error, and point estimate minus the margin of error. It's going to be X bar plus and minus the margin of error. Okay, what's the margin of error in this case? Well, in this case, it would be T star times S over the square root of N. Now, I don't have S. Okay, I can figure out what T star is based on N, the 200 students, but I don't have S. But that's okay, because we know that this whole thing is 18. Okay, so all we have to do is take 212 and add 18, and take 212 and subtract 18. And what we're going to get is we're going to get 194 and 230. Okay, for that. Okay, scientist is studying the effect that classical music has on students. Okay, students studying for statistics test. She chooses a random sample of statistics students and forces them to study in a room playing classical music. Another random sample of students are put in a silent room to study. After gathering results from the test, the scientist uses StatCrunch to obtain the following two sample t-tests. Summary, to test if classical music can raise students' test scores. She uses the null hypothesis that mean scores for both groups are equal. Okay, so the difference is mu1 minus mu2. Okay, right, an appropriate conclusion. Well, what would be the hypothesis, the hypotheses in this case? Well, it would be mu1 minus mu2 is equal to 0. the difference is nothing. Okay, what would be the alternative? The alternative is that there is a difference, that mu1 minus mu2 does not equal 0, that there is some sort of significant difference. Okay. Okay, the p-value is 0.07. So if the p-value is 0.07 and that's greater than 0.05, then what do? We accept the null, we fail to reject the null, and we reject the alternative. Okay, so what does this tell me? This tells me that there is no significant difference between the two groups of students. Okay, no significant difference between the two groups of students for that. Okay. Okay, number 27. Let me go get a glass of water. I'll be right back. Okay, been talking a lot for the last hour and a half. Okay, Mike is performing. Oh, yeah, let me go get something to drink. Sorry. Okay, it's a good place to get a pause. I'll leave this up. Okay, I'm back. Okay, Mike is performing a one-prob z-test to see if the proportion of classrooms at his high school is greater than 0.38. He randomly sampled 120 classroom students and finds the test statistic to be 1.35. Calculate the p-value. So here they give me the test statistic. Okay. And we want to calculate the p-value given the test statistic. So it's a proportion, it's a z-test. So we know that we have a z-value, okay, of 1.35. And so I'd like to know what the p-value is. Okay, p-value is. Okay. Okay. So we want to use normal CDF to get the p-value. So we're going to go on. We're going to go second vars, and then we're going to go normal CDF. Okay. And we're going to say from 1.35 to positive infinity. Okay. And they already do it. It's already z'd out. So let's do paste here. And it's 0.089. So the p-value is 0.089. The calculator there. Okay, Martin. Okay, Martin is performing a hypothesis test to see if the mean number of pages of the books in his library is greater than 440. He randomly sampled 60 books and finds an average of 483.74. This guy has way too much time on his hands. Okay, and the standard deviation of 154. Like, who cares? Martin, you gotta go outside, bro. Okay. Okay. Calculate the test statistic using the formula. Okay, calculate the test statistic using the formula. Okay, let's see, could we calculate it not using the formula? I don't think we could. Because do they give us enough information here? We want to know, so this is a mean, right? So this is a mean. Okay. And he finds these S is the standard deviation. So that we have S here. So I don't know. It might just be easier to do it by hand. So T is equal to X bar minus mu all over S over the square root of N, right? Okay, so again, I'm just thinking, can we do this through the hypothesis test? Okay. Let's do a t-test and see if we could do this with a t-test. What is it asking for? Nope, not a z-test. T-test. Do we have enough data to run this? He thinks that it's 440. It's greater than 440. Okay. We come out with an average of 483.74. Oops. 43.74 with a standard deviation of 154. Okay, and the number of books that he has is 60 books. 60 books, and we want this to be greater than, I think. The books is greater than 440. Yep, greater than. Let's calculate this thing out. And it tells me the T score is 2.2, which is exactly what it is. Okay, so you could have the calculator do, okay. So when we calculate this out by hand, it would look like this. It would look like 483.74 minus 440 all over 154 all over the square root of 60. Okay, and if you were to calculate that out, you get 2.20. Okay, which is what the calculator gave us. Okay, Crystal. Oh, Crystal. Okay, Crystal is performing an experiment on her kindergarten students. That's not, is that legal? I don't know. You shouldn't be experimenting on kindergartners. She assigns half of the students to play outside and half of them to play inside during recess. Oh, okay. After a week, she tests them on reading sight words to see if there was a difference in the mean number of sight words the students were able to recognize in 2 minutes. Okay. How would you write the null and alternative hypothesis? There's 2 different ways. So we're comparing group A to group B, right? And the number of sight words. Okay. So, okay, she tests them on the number of sight words. Okay. So that would be like an average number of sight words, I guess. So, you know, so HO is that mu1 is equal to mu2. Okay. Oh, sorry, it's equal. It should be equals mu2. Okay, HA is that mu1 is not equal to mu2. It's a difference. Yeah, see if there is a difference, not a greater or less than mu2. Okay, what's the other way to write this? Well, it's HO is mu1 minus mu2 is equal to 0. And HA mu1 minus mu2 is not equal to 0. So those are the 2 ways that we could write that there. Okay, Hector is campaigning for city council. I did not know that. Way to go, Hector. Okay, and is conducting a poll to predict the outcome. In order to win, he must gather more than 50% of the vote. He uses a hypothesis test at 1% level of significance. write a sentence that describes the type 2 error here. Okay, so type 1 error, is to falsely reject the null. Okay. So type 1 error, or sorry, type 2 error is to falsely okay, fail to reject the null or falsely accept the alternative. Wait, is that the same thing? Let me think about this for a second. Okay, falsely reject the null. Okay. Okay, and then there's a falsely fail to reject the null. So we fail to reject the null, which means we would falsely reject, type 2 error is to falsely reject the alternative. Reject alternative. Okay. Okay, so falsely reject the alternative. Yeah, that makes sense. So type 1 error is to falsely reject the null. Type 2 error is to falsely reject the alternative. Okay, so if we're falsely rejecting the alternative, okay, so what would be the null in this case? The null would be that he needs 50% to win. Okay, that would be the null. Okay, and so we would falsely accept the null, right? We would falsely accept the null. We would falsely reject the alternative, which means that we would falsely accept the null. Okay, we would falsely accept the null. Okay, that makes sense. Okay, so it says write a sentence that describes the type 2 error. Okay, so let me erase this. Write a sentence. So we're going to falsely accept that he gets 50% where what is the alternative going to be? What's HO? What's HA? HO is that P is equal to 0.5. HA is that he wins. In order to win, he must gather more than 50%. So yeah, the alternative is that he wins. Okay, he wins. Okay, the null is that he loses. Okay, so but that's false. He actually won. We predicted that he lost. Lost is our prediction, but he actually wins. So that's called a type 2 error. We predicted that he lost, but in reality, he actually wins. Okay. Okay, so we predict he loses when he actually wins. So that's the type 2 error there. Okay. So we would accept the alternative when or we would accept the null when it's wrong. Okay, number 31, Crystal is performing an experiment on it. We already know that Crystal is psycho and she wants to experiment on kindergartners. Okay, she assigns half the students to play. Yes, I get it. Okay. She finds a p-value of 0.06. Write the appropriate conclusion at the significance level of 0.10. So this is a significant level of 0.10. So 0.06 is less than 0.10. So what are we going to do? Yep, we're going to reject the null and we're going to accept the alternative. So what's the conclusion? The conclusion is that there is evidence, there is sufficient evidence to support claim that the students in the different groups performed differently. So the students, I'll just put performed. I'll just say knew a different amount of sight words. Boom, that's it. Okay. Number 32, practice, practice, practice the stuff that we went over at the beginning of class. So practice, 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 the 5-step methods. You'll have 5 of those on the exam. Okay, at the very end, the rest of it's going to be multiple choice. Okay, the exam is in Canvas, and I'll see you on Thursday. Okay.
I'm sorry, Professor, what was that again? What did you say? I'm sorry, I zoned out for a second.
I said that you need to practice what we went over at the beginning of the class, that you're going to have 5 hypothesis tests on the exam. The exam will be in Canvas, and it will be on Thursday at 6 o'clock. And I will see you on Thursday.
Thank you so much.
Sure.